The Moon has an atmosphere so tenuous as to be nearly vacuum, with a total mass of less than 10 metric tons, 9.8 long tons, 11 short tons. The surface pressure of this small mass is around 3 times 10^15 atm, 0.3 npa. It varies with the lunar day. Its sources include outgassing and sputtering, a product of the bombardment of lunar soil by solar wind ions. Elements that have been detected include sodium and potassium, produced by sputtering, also found in the atmospheres of Mercury and Io, helium-4 and neon from the solar wind, and argon-40, radon-222, and polonium-210, outgassed after their creation by radioactive decay within the crust and mantle. The absence of such neutral species, atoms or molecules, as oxygen, nitrogen, carbon, hydrogen and magnesium, which are present in the regolith, is not understood. Water vapor has been detected by Chandrayaan-1 and found to vary with latitude, with a maximum at ~60-70 degrees. It is possibly generated from the sublimation of water ice in the regolith. These gases either return into the regolith because of the Moon's gravity or are lost to space, either through solar radiation pressure or, if they are ionized, by being swept away by the solar wind's magnetic field. A permanent asymmetric moon dust cloud exists around the Moon, created by small particles from comets. Estimates are 5 tons of comet particles strike the Moon's surface each 24 hours. The particles strike the Moon's surface, ejecting moon dust above the Moon. The dust stays above the Moon approximately 10 minutes, taking 5 minutes to rise, and 5 minutes to fall. On average, 120 kilograms of dust are present above the Moon, rising to 100 kilometers above the surface. The dust measurements were made by LADEE's Lunar Dust Experiment, LDEX, between 20 and 100 kilometers above the surface, during a 6-month period. LDEX detected an average of 10.3 micrometer moon dust particle each minute. Dust particle counts peaked during the Geminid, Quadrantid, Northern Taurid, and Omicron Centaurid meteor showers, when the Earth and Moon pass through comet debris. The cloud is asymmetric, more dense near the boundary between the Moon's dayside and nightside. In October 2017, NASA scientists at the Marshall Space Flight Center and the Lunar and Planetary Institute in Houston announced their finding, based on studies of Moon magma samples retrieved by the Apollo missions, that the Moon had once possessed a relatively thick atmosphere for a period of 70 million years between 3 and 4 billion years ago. This atmosphere, sourced from gases ejected from lunar volcanic eruptions, was twice the thickness of that of present-day Mars. The ancient lunar atmosphere was eventually stripped away by solar winds and dissipated into space. The Moon's axial tilt with respect to the ecliptic is only 1.54 to 4 degrees, much less than the 23.44 degrees of Earth. Because of this, the Moon's solar illumination varies much less with season, and topographical details play a crucial role in seasonal effects. From images taken by Clementine in 1994, it appears that 4 mountainous regions on the rim of Peary crater at the Moon's north pole may remain illuminated for the entire lunar day, creating peaks of eternal light. No such regions exist at the South Pole. Similarly, there are places that remain in permanent shadow at the bottoms of many polar craters, and these craters of eternal darkness are extremely cold. Lunar Reconnaissance Orbiter measured the lowest summer temperatures in craters at the southern pole at 35 K, 238 degrees C, 397 degree F, and just 26 K, 247 degrees C, 413° F, close to the winter solstice in North Polar Hermite Crater. This is the coldest temperature in the solar system ever measured by a spacecraft, colder even than the surface of Pluto. Average temperatures of the Moon's surface are reported, but temperatures of different areas will vary greatly depending upon whether they are in sunlight or shadow.